The concept of speed is really one of the most familiar things in all of physics. Many times we think about how fast something is going, when really what we're talking about is the rate at which distance is covered when something is moving. When you take the distance that something travels and you divide by the time that it takes to do that distance, you're really talking about the concept of speed. Speed really can also be thought of in two ways. You could think about the average speed of something over a long distance, or you could think about the instantaneous speed of something at any moment in time. Really, they're the exact same concept. It's just how much time has elapsed when you talk about it. The unit of speed will be really any distance divided by any time. In physics, we often talk about miles per hour or meters per second, sometimes feet per second, sometimes kilometers per hour. If I ever talk about the equation that I use for average speed, it really is just simply this relationship right here. This relationship right here says that the average speed that an object has is equal to the distance that it travels divided by the time it takes to travel that distance. I can also rearrange this equation for distance or for time if I needed to solve for those variables in any particular problem. Let's do a very simple example where we can see how this average speed equation can be used. In this example, the problem says a man travels a distance of 25 miles in 3.4 hours. I want to know what his average speed is. This is really a pretty simple problem. Most people can do this very easily without thinking about it much, but I want to use this problem as an illustration to show the proper way to solve problems in physics. Whenever you solve a problem in this class, the important thing is to communicate the solution in a way that your teacher and that your classmates could understand. And so the proper problem-solving method really includes these four things. Whenever you show a solution, you must list the givens, you must list the equation that will be used to solve the problem, you must list the setup with units, and the answer that is circled around it. This is really important so that other people can look at your solution, and if you didn't do something right, they can see what you did wrong very quickly and very easily. So for this problem, the first thing I would do is I would list the givens that this problem had. In this particular problem, you know that the distance is 25 miles, and the time it took to travel that distance is 3.4 hours. I just use the letter D here. It's oftentimes important to just have an abbreviated unit for your variables, and so here I've got D equals 25 miles and time is equal to 3.4 hours. That's the first step. In the second step, I want to list the equation that I'm going to use to solve this problem. I'm going to use the average speed equation, which is that average speed is equal to distance divided by time. Now this third step, which is the setup, looks like this. I basically have substituted in the givens into the equation that I'm going to use in the right places, and I've included the units. This is really an important step and one that people often leave out. This is one way that you're going to be able to check your problem as you're doing it to make sure that it's going to work out right. Finally, the last step is to write down your answer, and it's always a good idea to just write down a pretty unrounded answer and then go ahead and round it in the end and circle it so that everybody can find it. In terms of how many numbers to round it to, these are things that we'll talk about later, but in this particular case I rounded it to 7.4 instead of 7.35, mainly because of the numbers that I had to start off with. The last thing I would like to address in this lecture are the alternative forms of the average speed equation. The equation as I have it written right here is what I would call the primary form of the average speed equation. But there are times that you might actually know the average speed of an object, and you might know the time that it's been traveling for, and you want to calculate the distance that it will travel. Well, when you do the algebra to isolate distance by itself, you come up with this equation. You would basically take the average speed of the object and you'd multiply by the time it would travel for. This equation will work as long as the time unit will cancel out the time unit that's in the average speed. There'll be some examples of this that you will see later on in the class. If that happens, then you'd just be left with a distance unit, which is what you're solving for in the first place. The other form of this equation would be if you knew the average speed of the object and you knew the distance that the object traveled and you wanted to know how long it took to do that. Well, doing the algebra yields this equation. This basically tells you that the distance divided by the average speed would tell you how much time it takes. Think about this very logical example. If I said that a car traveled with an average speed of 65 miles per hour, and it traveled 65 miles, I'd want to know how much time that took. Well, 65 miles divided by 65 miles per hour would be 1 hour. It's a pretty logical answer to that problem. All right, well, good luck using the average speed equation, and as always, if you have any questions, please come see your physics teacher. Have a great day.